This is the makeup video to show that the Euclidean distance satisfies the third condition. When I tried to show it in the class type, I thought it was very easy. However, it was quite complicated. So you guys don't need to remember all of this proof, but please just understand the concept, okay? This one is quite complicated and it's little bit beyond our class. However, if you finish the middle school and high school, especially the mathematics in the middle school and high school, you can easily follow the way. So let's take that. What we want to show is that d x comma y is less than or equal to d x comma z plus d comma y. And d x comma y is summation x I k minus y k square root and 1 over 2. Okay. So we show it in by using the quadratic equation and Cauchy-Schwarz inequality here. Let's put P is x minus z and Q is z minus y. Okay. And first, we will consider for a real number c, let's think about square root of b1 minus c q1 square plus bn minus c qn square. And square is, we know, p1 minus c q1 square plus pn minus c qn square. And if we expand all of them, then we can find that p1 square plus pn square minus 2c p1 q1 plus p2 q2 plus blah 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 pn qn plus c square q1 square dot 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 qn square. Okay, so and we know this one is always greater than or equal to 0 because this value is the square root of this square of this value. So this one should be always greater than or equal to 0. So if we see this formula as the quadratic equation in terms of c, then we can make the discriminant value, we know, b squared minus 4ac, which is this one. B is minus 2 p1 q1 plus pn qn square minus 4a is q1 square qn square and p1 square pn square should be less than or equal to 0 because this value is always greater than or equal to 0. So if we can derive a inequality that p1 square plus pn square plus q1 square qn square is greater than or equal to p1 q1 pn qn square. Okay, let's say this one as star. Then let's think about this formula. Square root p1 square pn square plus square root q1 square qn square and take a square here. Then it will become p1 square pn square plus q1 square qn square plus 2 p1 square pn square q1 square qn square. Okay, and by this star, this one is greater than equal to this one. Okay, so this one is greater than equal to p1 n square q1 square qn square plus, if we put this value to here, then we can make it two p1 q1 plus pn qn. Oops. And we know this one is p1 plus q1 square plus p2 plus q2 square plus pn plus qn square. Okay, so taking square root on both sides, then we can get p1 square pn square and square root plus square root of q1 square plus qn square is greater than or equal to square root of p1 더하기 p1 plus q1 square pn plus qn square. And please input this value here. Then p is x minus z, so square root of x1 minus z1 square plus xn minus gn square plus q is yz minus y, z1 minus y1 square plus zn minus yn square is greater than or equal to p plus q here p plus q is x minus y. So this one is the x1 minus y1 square dot 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 plus xn minus yn square. So this one, we know this one is the distance between x and z, this one is distance between z and y, and this one is the distance between x and y. So we can conclude that the x comma z plus dz comma y is greater than equal to dx comma y. Okay, that's it. However, it is a little bit beyond our class objective, so you don't need to remember it. But please remember the three conditions that the distance metric should satisfy. Okay, thank you for listening.